Today we'll design the shown two-stage OTA using the Analog Designer's Toolbox with the shown specifications in just 2 minutes. This is the Analog Designer's Toolbox interface, and this is an empty project. The first thing to do is to load the lookup tables. There are lookup table examples existing already inside the tool. Now let's load the lookup table examples which are existing in the tool. One is for NMOS and the other is for PMOS. Now, let's go to design our OTA. We go to DDB Generation tab, which is for Design Database Generation tab. And this is the library which includes the design classes where we can design voltage amplifiers, references, regulators, current mirrors, and GM circuits. We have many compensation techniques, but we need Miller compensation technique. And this is our proposed two-stage op-amp with PMOS input pair that we're going to design. Degrees of freedom that we can control. We just specify the range of each parameter. For example, in our design specs, we shouldn't use a device length more than 500 nanometer. So we simply put the maximum length to be 500 nanometers. You can also achieve your design specs across all corners. This is the nominal values of our design. VDD is 1.8 volt, Cout is 500 femtofarad, and you can add more corners, for example if you need to vary your supply and also your Cout, CC, and RZ. In Settings tab here, we have number of points in the DDB and you can increase this number as you need. Finally, we generate our DDB and save it. Then we go to Design Cockpit and add the DDB that we just saved. Here we have the degrees of freedom of the circuit on the left side, and on the right side, we have the design specifications. Now we have to drag the sliders to apply constraints for each spec. We need a DC gain of 1K, which is 60 dB. So we just drag the slider here and we can also write the value directly here. Now we need a unity gain frequency of 100 MHz, so we just drag the slider for UGF to the value. Also we need a phase margin of 70 degrees at least, so we drag the slider to the value. The power consumption spec is our design is to be minimized. Simply we just right click on the current slider and choose Send Minimum to Tune. This will get the specs achieved with minimum power consumption. We have all channel lengths, we have all GM over ID values, the current values and everything. On the right we have all the specs and widths for all devices. This was how to design a two-stage op-amp with Miller compensation in just 2 minutes with understanding everything we are going to change.